And then it created 4 separate subfolders for each of the quads, and you can see the name of the quad here in the subfolder name, and it tells you what the data is by in the file name, which is, as you can see, is very long, overly long. It's too long in our case. I like to clean those up a lot of times by shortening down to no more than 8 or 10 characters. But in this case, I'm just going to leave them as they are for the sake of this example. It won't hurt anything this time, and it helps us to clarify what data is located within which subfolder. If we had created our own subfolders for each quad and each data type, then we would want to move those files in there appropriately. But in this case, for the sake of time and example, I'm going to go ahead and leave them. But just note that when you're working on an actual project, you'll want to clean these up a little bit by having some more properly named subfolders and such. So we'll leave those for now. And if I go into one of those, you can see that it's processed quite a bit of information. And a lot of this information we won't actually use. But just to give you an idea of help you to understand what we have here, I'm going to sort it by name, and you can see that we've got, for example, a hydrography with a PC01 named after it. And there would be 3 of those related files. You've got the shape file, the dbase file, and the shx file. And you have that same pattern for several other shape files that gets created. You've got the PC01. I'm getting that out of the name here, and we have the N001 and the NP01. Okay, 2 more. The NE01 and the LE01. Okay, and we also have a document file in here. We have several other dbase files. Again, most of these, if you're interested in exactly what all of these files are, then I can give you more information about that. For our purposes, just what we want to need to know for now is the LE01 are the files that we're going to be using. So I'm highlighting those here, and just make a note somewhere that the LE01s are the ones that we want to use. These other files have various types of topology in them, which we've talked about that term a little bit, and they basically have things like the nodes, where the hypsography, in this case hydrography, where the various streams and such intersect. Other features, there'll be a node put there. There's a layer in here that includes like the bounding rectangle for that quad. There's several other topology types of layers in here, and so this program it's nice that it does that, because you might use those in certain cases, but usually the files that you want are in the LE01 coded file. There's also a document file in here, just to point out. I'm going to open that so you can see it. It is a metadata type file that was embedded with those with that download, and in there should be some clue as to the projection that was used for that. Now, in this case, we're lucky that this particular utility, the DOG to shape, does a good job of processing the information for us. But just for reference, you've got this metadata file here that's been created, and it lets us know that the reference system is UTM. The datum, in this case, they use an abbreviation called NAS. And the NAS datum is sort of a code that USGS uses in their Spatial Data Transfer Standard format, the SDTS format, and it basically is representing the NAD of 1927. So anytime you see NAS, which you won't see very often, mainly you'll just see it with DOG data, but NAS equals NAD 1927. Just remember that. Now, if it was let's see, if it was NAX, okay, instead of NAS like in SAM, if it was NAX like X-ray, then that would be an NAD of 1983. So it's important information to know. You'll run into that again with the DOG data, but you probably, like I say, you probably won't run into it with other data types. And then the zone again here is zone 11. So we've got that information. So let's go now into our catalog again and open this data up and see if it has been defined, if the program did or definitions of the projection for us. So since we had the program open before we did our processing, it's not going to see those files yet. So what I'm going to do is I'm going to select the working folder, the EXER1, and I'm going to go up here to refresh. So if I go to view, I can refresh, and it will refresh those subfolders under the EXER1. So then I can open it up and it should see the data in there now. So remember to do your refresh, and again it sees all the different data types, and just remember the one we're interested in this case is the LE01, and I'm going to click on that. If you want to preview that, you can, just to confirm that that is likely the one we're interested in. We should see a lot of streams pop up. And there's other information here. We've got the streams, but notice too that we also have this bounding rectangle here, and this can be a when we have more than one quad that we're looking at, like we will in this case, that can be a little bit of a pain. So we will want to take that line out so that it's not interfering. It's basically just the bounding rectangle off of the quad map that gets embedded with the data. But let's check and see. Let's go back to contents and let's open up our toolbox and see if that layer has been defined or not. So we will take that and drag and drop, and it says unknown. So the program did a good job of converting it into a shapefile for us. And the program, what's interesting is the program knew that it was using a UTM Zone 11 projection, because if you noticed in the dialog when it was processing, you could see that information scrolling through, but it did not define that for us. So it's not actually been defined. So we'll need to define that. And remember, if you do, not likely that you caught that information while it was processing, but we did have the metadata file that we looked at, and I shared with you that the NAS, like in SAM, NAS equals a 1927 datum. So let's go ahead and set our datum then, or our projection then, using that information. So we will select projected, and we want UTM, and this time we want NAD 1927. And now this is going to cause us some issues a little later that we're going to have to resolve. Mainly we'll have to do a reprojection, but I'm walking you through this so that you'll see that process, because again, our other data was, our raster data was in a 1983 datum, and anytime you have two different datums like that, you always have a potential for your data to not line up correctly. So we're going to need to reproject that, but first we have to define it in what it actually is stored in. So it was stored in 1927, zone 11. We add that, apply, OK, and then say OK. And then do the same thing for all of your other 4 quadrangles and data types. Basically, we'll expand. We're not going to define projections for all the different shape files in each of these subfolders, just the LEO1. We'll go ahead and do that now, and I'll pause the video while you're doing that for each of the other ones for the LEO1. Okay, I've finished that on my end for all 4 of the quads. I went in and processed just this LEO1 layer in each one of those and made sure that the projection was defined to UTM NAD 1927 zone 11. Now, since we've got everything defined, and we notice we haven't even opened Arcmap yet. But before we do, then there's one more step we need to take with this DLG data. As I mentioned before, because the datum is different, we're going to need to reproject that into a 1983 datum in order for it to line up properly. Now note that Arcmap does a really good job of what we call projecting on the fly, or reprojecting on the fly, as the case may be. We could open all of the information we have, including the base data and this DLG data, and Arcmap will try to take this DLG data and line it up with the raster data. But because the datums are different, there's going to be a noticeable shift in that. If the datums were the same, the coordinate system being used would not be an issue. It would line those up just fine. But the program does a lot better job than it used to of trying to line up based on the different datums. But it's basically impossible for any program to get 100% alignment there, because with the datums being different, they just have that different reference point that makes it impossible to get 100% alignment on that. So to save that problem or avoid that problem, we're going to go ahead and reproject. Now note that we could reproject our raster data if we wanted to, but in that case we would be reprojecting from 1983 to 1927 datum, which is an older system. So it's much better to go ahead and update our older 1927 datum data into the 1983 datum. And so really the only question becomes is which coordinate system do we want to use. And since all of our data is in the UTM coordinate system already, then we'll just keep it in the UTM coordinate system. So what we'll basically be doing here is reprojecting from UTM 1927 on the DLG data into a UTM 1983 datum. So let me show you how to do that. So we've already got our toolbox open. We've already defined our projections, which you have to do first. And so now what we want to do is we're interested in feature data. So let's expand that tool. And you'll see we have a tool called Project. And this is what I was telling you before, that to me it would be much more appropriately named if it were Reproject instead of Project. But because that's basically what we're doing, is we're going to reproject with it. But that's the tool we want. So go ahead and click on Project. And for this dialog, we first want to bring in, of course, the layer that we want to reproject. So let's go ahead and start. We have 4 of them. So let's go ahead and start with the first one. And again, it's the LEL1 data that we defined before. I'm going to drag it and drop it in there. And if everything is right, it should know what the coordinate system is already. So we shouldn't have to input that information. A lot of times it will tell you right here what that projection is, but it's interesting in this case that it's not telling us that, but sometimes it does, I've noticed, and sometimes it doesn't. So then we want to give it so we've got a name for it there, and then notice by default it gives it an output name by default. And basically what the program does is it tacks on this project underscore and in the word project at the end of your file name. In our case, that's really getting so long, and it doesn't tell us in the name that it's 1983 datum type data. So let's go ahead and clean that up just a little bit while we have the opportunity here. So we already have a subfolder that's out here called Half Dome, Hydrography, so forth. Let's go ahead and just let's create a new one. Let's click on the dialog over here, and we'll route over to our working folder again. Oops. In DLG, let's expand that. And let's go ahead and, in this case, let's create a subfolder here in the DLG folder. And let's call it, let's just call it let's call it UTM NAD 83. Okay, and this is where we'll store all of our data for this example. That way we'll have it all in a little bit of a cleaner folder at the same time. Now if we go in there, if we want, we can go ahead and separate. Let me jump into that folder and let's create a new folder, one called Hydrography and one called, oops, I accidentally created a subfolder within the hydrography. It's not what I wanted to do. Let me take that out. and it's actually not letting me delete it here within this dialog. I'll have to go into Windows Explorer to delete it, so I'll do that a little bit later. Let me go back up, and what I wanted to do was create one and just call it contours. And let's just change our name from hydrography to streams while we're at it. How about that? That would make it a little bit more intuitive. We've got streams and contours, and both of these are under the UTM NAD 83. And we're wanting to set the folder for the layer that we're creating. So that one is the hydrography, so that would be streams. And again, just ignore this new folder for now. We'll delete that a little bit later. And let's just give it a name, and we'll call it, how about HD for Half Dome Streams. And click Save. And you can see we've now redefined our path where we're storing the information and the name. And the program will add the .shp on there for us. You notice I don't have shp on there, but it will add that. It will add that for us. So here we pick the output coordinate system, and this is what we want it to be in. Not what it's actually in this time, but what we want it to be in. So we select. We want projected, and we want UTM. This time we want NAD 1983. And we still want the zone 11. We apply, say OK. Now we'll get to this geographic transformation dialog, and in this case, since we're going from one datum to another datum, we do want to apply a transformation. That's sort of a necessary thing to get a more accurate data set. So from that, we're going to select the drop down, and we want to go, it's sort of intuitive, we want to go from the NAD 1927 to the NAD 1983. The option we want here is the NADCON, the NADCON option. So make sure you pick that one, and it adds it to your little dialog at the bottom, and then you can say OK. And it takes this one just a minute to run, just like we did with our defined projections, and it's finished on my end, and the little dialog pops up saying project is completed, which you're not seeing here again because it's in my other window. So we've now reprojected that, and if we look, we should find that data layer in our subfolder there, and indeed we do. I think we can take the new folder out from here while we're there, so let's go ahead and do that. There we go. So now we've reprojected the stream layer for the half dome quad. So now let's go ahead and do the other three layers we have. So we'll project, and we want to this time pick the second layer, which was the hypsography on half dome. Drag that in and drop it. And again, let's rename the file in the folder. It remembers the last folder we were located, which was streams, so we don't really want that one. We wanted the contours. But let's stick with the same naming scheme. We'll call it HD and contours. Save. Output coordinate system again. Select that to be projected. UTM. NAD 1983. You have to be careful. I'm going pretty fast through these, but it's easy to accidentally click the wrong one. So always check your dialog when you get back out here to make sure it is what you wanted for the name. And then the transformation again. We want to apply the 1927 to 1983 NADCON. Say OK. And I'm going to pause this while I'll go ahead and I'll do the other two for the Yosemite Falls quad. Save time. And I finished with all four of those. I'm going to close the Arc toolbox. I'm going to close up my subfolders where the original data was, and then look into the new folder we created, the UTM NAD 83, and I'll expand those two folders there. And you can see I named the second round, I called it just Y Falls Contours and Y Falls Streams. So we have that information, and so this represents our reprojected data, and now we should be able to finally go into Arcmap and start pulling some of these layers in and seeing how they line up. Just for a preview, if you want to make sure your contours is where you were expecting, you can click on that and can See, indeed, it does look like contours. Same thing for the half dome. And this data will make more sense once we pull it into Arcmap and have a base map underneath of it. So that's the processing and how you would process the DLG data, define your projections, and if needed, reproject as needed. So there's a lot of steps there, but this should give you some practice with that. So now we're finally ready to go into Arcmap. So let's close Arc Catalog. And then once that closes, open up Arcmap. And my Arcmap is open in my second window again, and because I'm recording in this one, I can't show you both. I can move the dialog over, but until I select something here, it won't let me move the main program window over. So just when you get this Getting Started window, go ahead and just click on Cancel, because we don't really need any of those projects that have been open in the past. And now I can move my other window over. So we've now basically opened a blank project in Arcmap. Now remember, when you pull data into this, we have data that we've made sure the projections have been defined and so forth. But in Arcmap, your view window, your view here has its own projection. And because it's a blank project right now, there's not been a projection defined. So if you look down here in the lower right, you see it says unknown units. So we don't have any projection defined. Now what Arcmap will do is the first layer that you pull into a project, it will set the data frame, what we call this is our data frame, everything under what we've got layers here. This is our data frame. It will set that projection for the data frame to whatever the projection is on the first layer that we pull in. So it's important to know that you can have a projection for your data frame totally separate from the projection for your layers. And so what I like to do and encourage people to do is go ahead and, before you pull any data in, go ahead and define what projection you want to use. As a shortcut, if you didn't want it to do it that way, you could go ahead and pull in the first layer that you want that has the same projection that you're interested in, which in our case would be the NAD 1983, because we've already reprojected everything into that. But just to be consistent here with what I'm trying to make you aware of, let's go ahead and define a projection for this data frame ourselves, rather than letting Arcmap default that projection when you pull a layer in. It's just a good habit, because you might pull a different layer in that you're not thinking about on the projection to start with, and that could cause you problems later on. So I'm going to go ahead and right click on layers, go to properties, and when it pops up, it takes it a minute here, and then I'm already in my coordinate tab, because that's the last thing I used in the properties when I was using Arcmap. But if not, go ahead and click on coordinate system and see how it says no projection defined right now. So we want to define one, and we want to go to predefined, and we want a projected one. So let's expand projected, and we want UTM, and we want a NAD 1983, and we want zone 11 north. And when I select that and apply it, it applies that to my data frame. I can now say OK, and the data frame has now been set up with a projection. And notice that it's using meters by default too, which is what UTM is using, so that's nice. So we now have our data frame set up the way we want it. So now we can go ahead and pull data into that data frame. So let's add data, and let's first pull in our topo map or DRG data, and we will have to route over to the working folder again. And we were interested in the DRG, and let's go ahead and just get both of those layers. I'm going to click on the first one and hold my shift key down and click on the second one, click on add. And in my case, I don't want to build the pyramids. In theory, that can make it a little quicker to reload when you're loading things, but if we had a lot of different quads, then we might want to build the pyramids, but just say no for now. And you have to say that for each layer, and it will load those layers. And if everything works fine, they should load, because they were trimmed, remember, they should load almost seamlessly here together. And so we can now go ahead and load some of our DOG data, and let's add data again. move out of that folder, go into DLG, go into the reprojected data that we created. Go into, let's do the contours first. And I'm going to click on both of those and add those. And it's loading. The one thing that's a little aggravating with Arcmap is that it automatically picks a color scheme for every vector layer source that it loads, and that's not necessarily the one you're going to want, and almost always will not be. And so we're going to want to change the colors on these. So let's go ahead and do that while we're here. And a quick way to change the colors is to just click on the symbol over here, left click on it in the table of contents, and that will pop up a dialog that has a symbol selector in it. And let's just kind of go with one that would match the quad as close as we can. We'll pick kind of a brownish color. And for now we'll leave it at a thickness of 1 and just say OK. And let's pick that same color for the Yosemite Falls. And that lets them match up a little better. And let's just zoom in to see kind of what we have here. And I'm going to zoom about in the vicinity of where those two quads meet. And you can see where it just happens to be the Yosemite Valley area, which is where the Yosemite Falls is. So let's zoom in a little bit closer. We can see some of this in more detail. And here we've got the Yosemite Village and the Yosemite Lodge area. And actually the falls, I believe, is in this area right here is Yosemite Falls. So you can see that. We got lucky there. So while we're there, just notice that the contour lines are lining up pretty good. We've got a pretty good alignment with them. You can see if I turn those off, you can see the topo map with the original lines, and I can turn these back on, and you can see that they line up really, really well. Now, if we had not done a reprojection and left it in the 1927 datum, we would have a real noticeable shift in the data. Even with Arcmap trying to reproject it on the fly, it would still be off more than this. So it looks really good. So let's go ahead now and pull in the stream data and see how well it lines up with some of the streams we're seeing on the topo map as a base here. I'll pull those in, and let's go ahead and change the colors on each of those to a bluish color. Get them the same. I will pick let's just pick this Grecian blue. And let's make these a little bit thicker so we can see them jump out at us here for the moment. And I'll do the same with the other quad. Pick the same color, thicken it up a little bit, and say OK. And here you can see that it looks like they are lining up really well also. And you can see when we get into the river, down here is the Merced River, or Merced, I'm not sure how you pronounce that, Merced River. And you can see it's got the banks on it. Each side of the river has a line for it there. But if I selectively turn one of those back off, you can see just how well it really does line up. So in this case, it's doing an excellent job of alignment. Sometimes you'll have a little bit more of a shift than this one. This one really is lining up well. So there you go. So now we have the raster layer for the topo map loaded. We have our DLG data loaded. I can turn this raster layers off, and you can kind of see what the DLG data looks like. Interesting that you can you can see how the DLG data really represents the vector data off of the topo map, and it's lining up well with that source, which you would expect since that was the source for the data. Now let's go ahead and pull in the other aerial raster data that we downloaded, just for reference there. That was in the DLQ this time, and we'll load both of those layers. And there we go. So if we want to, we can zoom in before I zoom in, I'm going to do something here that you might want to practice occasionally. Once you find an area that you are interested in case it might be hard to find, again, it's nice to set a bookmark for that area. So I'm going to go up here to bookmarks, and I'm going to create a bookmark, and I'm just going to call this Yosemite Village overview. Okay, and then we can zoom in a little bit and sort of look at areas a little bit more closely, see how they're lining up. And then we can always go back to our previous zoom just by clicking on bookmarks again. So here, when we look at it here, you can see it does a pretty good job. It's off just a little bit in places, like you can see the river here is a little bit off, and that's just the nature of the data. The topo maps have a certain amount of error in them, and there also could be potential error with the registration of the aerial photo. So it's hard to say at this point, and I wanted to point this out because a lot of people misunderstand this, but it's hard to say which source is most correct at this point that we're viewing right now. Your instinct is to say that the vector data is off a little bit because we tend to trust an aerial photo more. But the problem could also be that aerial photo was not registered 100% correctly. There's a lot of distortion in the aerial photos that has to be accounted for when they're processed, and somewhere in that process things could have got shifted a little bit as well. So it's hard to say which one is exactly right, and in either case they're very close, and so that's what we want to see. We want to basically at this point see something that is very close. We're not expecting it to be 100% alignment, but we are expecting it to be pretty close, and that's important to note. So we've got that. If we want to, we can go back to the previous. We can pan around, for example, and look at things here. And anytime we wanted to go back to that initial view we had, we can just go back to our bookmarks and click on the view that we'd saved before, and it will zoom us back out to that extent. So one last thing about this to note is that you'll see this black line in here, and this black line is representing overlap between the two images. And it's unfortunately there's a limited amount of things you can do to deal with that. It depends on the source that you get it from as to how much that's an issue. And in this case, one of the two is overlapping the other one. Okay, so we can selectively turn one off, and you can see that the black is showing up under that. Okay, we turn it back on, turn the other one off, you can see that the black is showing up from the lower quad there. So one of the things that we can do if we want to get that black out of there as a temporary fix is we can assume that it's a color of 0 since it's dark black. It's basically no data, an area of no data. We can go into well, actually I'm not going to go there right now because the way this is set up, it's using a color scheme that it makes it more difficult to actually change it like I was about to do. I will save that for a later exercise, but for now we'll leave it like it is. We've got our data, everything seems lined up, and we don't want to overcomplicate things with this first hands-on exercise, so we'll look at that a little bit later. But there you go. Now you've got a project. Let's save that project. It's still not been saved, so let's save it. And we'll route it again over to our working folder. And this time I could create a folder called projects if I wanted to, which is probably not a bad idea. Let's just go ahead and do that. We'll make us another, and I can make a new folder right here in Arcmap, and I'll just call that projects, and this will be where I'm going to store my MXD file, and I'm going to call it EXER1 space overview. And say, actually, just call it, to make it simple, let's just leave it at EXER1. And we'll save it. And now you've got a project completed. So that should complete exercise 1. Now what you'll want to do with this is you'll want to zip up your data folders to upload them to the Dropbox. And the way we can do that, let me just demonstrate that for you so that you can get the data that you need and save some space. I'm going to come back out. And we created some other folders that we haven't used, the Tiger folder in particular, and we'll add to this exercise a little bit later. That's why I went ahead and created it here for now. So what I'm going to do is, you notice I'm in the EXER1. I have all the subfolders that I created. All of my data is within those subfolders. And to save space on your upload, since I already have the imagery files on my end, which are the big files, so in this case the only one we really need is the projects and the DOG. I can hold my control key down and it lets me select each of those independently. Now we don't have anything in base data, we don't have anything in the Tiger folder just yet. We'll save that for later. And we don't need the imagery, so just those two is all we need. And if you right click while you're on top of either of those two, it can be either projects or DOG, either one. Just make sure your mouse is on top of one of the ones you have highlighted, and right click. Make sure to right click and not left click. If you left click, you'll lose your selections and you have to reselect it. So I'm going to right click, then I'm going to scroll down to the WinZip, and then I have a handy option here for add to EXER1. And I think you'll get that same thing with 7-zip. If you're using 7-zip, you can go in there and add that to EXER7Z. So that will work just the same. So we'll go ahead and select that, and that will compress our files for us. And mine's showing up in the other window so you don't see the background image. Give it just a minute here. And there we go. So you should end up with a file, it looks like, with WinZip around 13.6 megs in size. And that's the file that you want to upload to the class Dropbox. And you'll see that it's going to contain all of the subfolders of the DOG and the projects folders. So we'll take that one, we'll go to the class Dropbox and upload that file. I think that should be pretty straightforward. And that completes exercise 1.